I'm going to use R to explain this problem. An arrow is launched straight up from the ground with an initial velocity of 23.4 meters per second. So here's the game, right? You and your partner has to come up with the correct trajectory to shoot an arrow to get to this target before time is up. Oh, red light, green light. Okay, so this is what you have to do. You have to get the correct trajectory to get there. So you already know that there's a force working against you. What's that force? You know that. Thank you. You know that gravity is working against you, right? Step out for a moment. Thank you.
Jamil, you get your girlfriend.
Okay, you know that gravity is working against you, right? So here is what gravity is going to end up doing. Hopefully it gets you to your target, because gravity might get you there. If you don't shoot it right, gravity might get you here, or gravity might get you all the way. Step out, please and thank you. I'm going to have to lock this door, because y'all wild. That can wait. Okay. Gravity can get you to the target before or after it. If there was no gravity and you shot this arrow, it would just keep going straight forever. But that's not the case, so you know that already. So now you and your team know this information. That means gravity is working at what acceleration right now against the arrow? Downwards at what acceleration?
9.8.
Not 9.8, but negative 9.8. So if you and your team shoot this arrow, you know that negative 9.8 is going to be working against you. So you have to make sure you angle it at a certain point so that you can hit that target, right? You have the initial velocity, which is how fast it's going to start moving the moment you shoot it, which is 23.4 meters per second. When you hit that target, what's the velocity? When you hit the target, what's going to be that velocity? What's the velocity when you hit the target? Nope.
2.38.
Nope. Because you hit a target. If it hit the floor, what's the velocity? Zero. Exactly.
Zero.
So the final velocity is going to be zero because once it hits that target, that's it. Uh-huh.
I get it.
This is why I said don't assume. Don't assume that it's only starting velocity can be zero. So the moment you have that, you already know what you're working with. You're solving time because it says how long. So final velocity equals starting velocity plus acceleration times time. This is going to be 0. This is 23.4. This is negative 9.8. This is t. Okay, you see that 0? I want to change that up. So how am I going to distribute it? What am I going to do?
I just know the answer.
I know, but how we get to the answer is very important. Subtract 23 on both sides. 23.4 on both sides. We want to get t by itself. That's the whole focus is we want to try to hit this before the time is up. So 23.4 on both sides. This cancels out. Then you have 23, I'm going to rewrite it here. Negative 23.4, right? Equals negative 9.8 times t. Again, we want to know how long it's going to take us to finally hit this target if we shoot it at this speed. That is the goal. The last group was so focused on what the highest point is, they forgot the point of the whole question. So be careful. So what are you going to do here with these two? Divide it. And when you divide it, Juan, excuse me. When you divide it to both sides, this cancels out. Then you have t equals negative 23.4 divided by negative 9.8, which gives you 2.4 seconds. So it'll take you about 2.4 seconds to hit that target, which is less than the time given, which if you were given 5 seconds to hit it.
2.4
seconds.
We
Yep.
would be dead.
I told her that. I said that.